All right, class, what I want to talk to you, I also want to talk to you about sig fig in lab, significant figure in lab. So it's a chemistry lab, you're going to go to lab, and in lab, you are going to measure things. When you measure things, you are going to report a number. Now the question is, how would you determine the number of significant figure for that number? For example, I'm going to go and measure 10 ml of hydrochloric acid. How would I know? Do I reported 10 ml? Do I reported 10.0 ml? Do I reported 10.00 ml? If I measure something in lab, how would I determine the significant figure in order to report the number? That will depend on what glassware you use. So you're going to go in lab, you're going to measure things, you're going to get a number. Now, then you have to determine how many sig fig you want for that number. So if I measure 10 ml of hydrochloric acid, is it just one sig fig? I just go 10 ml, or can I just say 10.0 ml? That would depend on the glassware you use in lab. So we're going to go over some of this glassware so you know how many sig fig they have and how you need to report the number. What are these? These are beakers. These are beakers. Do you think, if you have a beaker, do you think beaker is accurate? What do you think? I'm going to give you a hint. If you break a beaker in lab, it's going to cost you maybe $10, $15. No, it's not very accurate. So if you want to break something, break a beaker. Don't break anything, but if you had to, the beaker is a good one to break. It's a little bit cheaper. It's not very accurate. So if I measured 10 ml of hydrochloric acid using this beaker, I cannot report any decimal places. I have to say 10 milliliters. So no decimal places is not accurate enough to have a decimal place. Okay. Now, what is these ones down here? These are flasks, right? What if you have a flask? Some people call it conical flask. Some people call it Erlenmeyer flask. They're flask. Now, do you think the flask is more accurate than a beaker? It looks fancier, doesn't it? Yeah, it has a little shape. It looks a little bit fancier than beaker, but it's just as bad. You cannot have any decimal places. No decimal places. So if I measure 10 ml, I should just report 10 ml. So if you tell me I measured 10 ml, then I know you didn't measure it accurately. I know it's not going to be exactly 10 ml. So no decimal places you can use when you have a beaker, and no decimal places when you use a flask. So far, so good? Okay. Now, the next glassware you're going to use in lab all the time are graduated cylinder. The two graduated cylinder I have here, the one on top is a 10 ml graduated cylinder. This is very common to use in lab. And the one down here is 100 ml graduated cylinder. Okay. Now, if I measure 10 ml of hydrochloric acid, if I use a 10 ml graduated cylinder, I can report 10.00 ml. Because 10 ml graduated cylinder is good to 2 decimal places. And I will show you at the end exactly why that is. Why is it graduated that way? So 2 decimal places, you'll see, is a lot more graduated. So I can be a little bit more accurate. 100 ml graduated cylinder is good to 1 decimal place. So if I measure 10 ml, I can say 10.0 ml I measured. So you go to lab, you measure it, and you're going to write down on a piece of paper, I got 10.00 ml graduated cylinder. When you do that, then I will know that, okay, you used something that was more accurate. So far, so good. Okay. The next two, you're probably going to see these more in Chem 1B class. The one on top, what we call these? These are called volumetric flask. Now, volumetric flask is not graduated. If you see, there is like one line. If you go back here, these are graduated, right? You can measure different amount. This is graduated. You can measure different amount. The same here. These are graduated. You can measure different amount. Now, volumetric flask has only one volume. It has only one line. So it's only one fixed volume that you could measure. Okay? Now, if I use 100 ml volumetric flask, what's the only volume I can measure? 100 ml. If I use a 500 ml volumetric flask, the only volume I can measure is 500 ml. I fill it up to the line. Do not go over the line. It's not graduated. If you pass this line, then you don't know how much you have. And as long as you go to this line, then you know you have 500 ml. The same here. You go all the way to this line over here. As long as you go all the way to exactly this line, then you know you have 100 ml. What happens if you pass the line? Oh, you got to start all over again because you don't know how much you have in there. Now, volumetric flask only has one volume that you can measure. It has a fixed volume. It's very accurate. You can do it to 2 decimal places. So if I use this volumetric flask over here, if I fill it up to the line, which is over here, hopefully you can see the line, then it's gonna be what? I'm gonna write down I got 100.00 ml. If I use this volumetric flask over here, again, the only option I have is fill it up all the way to the one line here. If I do that, then I can write down 500.00 ml because it's good to 2 decimal places. So far, so good. Beautiful. We're almost there. All right, what is this guy? This is a pipette. Okay? If you look at a pipette, it also has only one line. It also has a fixed amount that you can take. It's not graduated. So if this one is a 25 ml pipette, what's the only volume I can measure? 25. Now, pipettes are also accurate. They're accurate to 2 decimal places. So if I 2 decimal places. If I use this pipette over here, the only volume I can get, if I fill it up to over there, is 25. I will write down 25.00 ml. Over here, this is a 100 ml. It says 100 on it. Again, there's a fixed volume. And if I do it, I would write down 100.00 ml. It's a fixed volume I can do. It's not graduated like these ones. These ones I can measure different volume, but pipette and volumetric flask, only one fixed volume you can measure. But they're pretty accurate, right? So don't break these things in lab. It's going to cost me a lot of money to replace. All right, ready for last one? This is a burette. You're going to have a titration later on. You're going to use a burette. And we're going to talk about this burette more later on. It's graduated. Starts on top, starts from 0. Down here is 50. You drain it and you can read how much you have. You have drained and you have added to your solution. Now, burette is also good to 2 decimal places. I need you to remember this. You are going to have. So if I measure 10 ml, that means I had 10.00 ml. So 2 decimal places. All right, let's go over this again. Beaker, no decimal places. Flask, no decimal places. 10 ml graduated cylinder, 2 decimal places. 100 ml graduated cylinder, 1 decimal places. Volumetric flask, burette, or pipette, those are also good to 2 decimal places. So these things really matter because by you doing the right number of significant figure, you're going to tell me how accurately you measured it. All right, I think you're ready for a practice problem. here's what I want you to do. Here's my 100 ml graduated cylinder. I'm not very good at drawing, just have a little bit of imagination. I added water to this, and what I want you to do, I want everyone to do this. Even though I can't see you, do it. I want you to write down, if you were in lab, write down what is this volume. Okay, so water is added to this graduated cylinder. Write down the volume. One thing you're going to notice, and you're going to notice in lab, that water has meniscus. Water is not flat. It's going to have a meniscus. Okay? We call this a meniscus. Water is going to have a meniscus. Okay? It's kind of like a concave shape. So how would you read this? You read, that's not one. Oh boy, there we go. You read the bottom of the meniscus. So you read, so water, and we're going to learn later on why that is, because water loves glass, so it actually tries to go and attach to the glass. So because of that, water has a meniscus. It's not going to be flat. So you're going to see in lab, water is not going to look like this. It's actually going to have a little meniscus. Okay, write down on a piece of paper, write down this volume. How would you report this volume? Now, I'm going to write down some of the volume that in my class people usually report. I was looking at my lecture notes from before. Someone said 48.5 ml. Someone had said 48.4 ml. You shout your answer too, even though I can't hear it. 48.6 ml. Someone has said 47.0 ml. And then someone has said 48 ml. Okay. First of all, don't forget to put the unit. A number means nothing without a unit. That's really key. Okay. Now, check this out. This is 40. I know this is 50. So this would be 42, 43, 44, 45, 46, 7, 8, 9, 10, and then 50. Okay. So up to here is 45, 46, 47, 48. Up to 48, I can easily measure. Do you agree? Up to 48, I can easily measure. But I can do a little bit better after that. Because this is a 100 graduated cylinder. So if you have a 100 graduated cylinder, you know you're good to one decimal place, right? So I'm going to cross this one out. So up to 48 is really easy to see. You can always do one more digit that is estimated. This is how you would have known that 100 ml graduated cylinder has one decimal place. Because up to here, you can easily read. We can go one more estimated digit. The last digit is always the estimated. So again, this is a 100 ml graduated cylinder. It should have one decimal place. Over here, we said it has one decimal place. So I can go 48 and I can do a little bit better. So here is 48. Then we said the last digit is estimated. So all of these numbers are okay. 47 is not okay. I didn't see that one. It's definitely not 47. It's 48. Let me redo this. There we go. So all of these numbers are okay because the last digit is estimated. The last digit is estimated. Someone might say, oh, this is 48.5. Someone might say, no, my eyes is a little bit better. I think it's 48.6. That's okay because last number is always estimated. Last number is always estimated. And that's okay. And sometimes when you read the label, it says plus minus 0.2, right? So these are all okay. These are all within the range. These are all okay. Yeah? Okay. Nice job. So we learned a lot today. We learned about when you go to lab next time and use different glassware, you're going to pay attention Before you write down your number, you go, okay, so what kind of glassware am I using? How accurately can I write down this number? Did I measure it accurately? There's one more part I want to go over to just make sure that you guys are really good with sig fig. One more thing. Okay, so I told you guys use 100 ml graduated cylinder, 1 decimal place. 10 ml graduated cylinder, 2 decimal place. But what if I hadn't told you that? You can also look at how graduated a glassware is to see what is the uncertainty of the device. Okay, and so let's look at this together. And there's water over here. Okay, if I were to read this one, how would I read this? I would say, this is probably around 1. And is this digit estimated? Yeah, because I can't really tell exactly. So I'm going to say it's probably around 1, right? Now, if I were to read this one and say, okay, I'm sure about 1. I'm sure about 1. And I can go one more digit that is estimated, right? So I'm sure about 1. It was exactly the same over here. I was sure about 48. And I'm sure what 49 is. So I can go one digit in between that is going to be estimated. So I know this is 1. I know this is 2. I can go one more digit that is estimated. And to me, this is more like 2, so 1.2. But again, this is estimated. So someone may have slightly different number, and that's okay. Now, when I go over here, I know 1 for sure. I know 1 for sure. And I even know is 1.1 for sure. I know is 1.1 for sure. And I can go one more digit that is estimated. So I know this is 1. I know this is 1. I know this is 1.1. And this is 1.2. So it's before 1.2. So I know 1.1 for sure. I can go one more digit that is estimated. And to me is 1.19 probably. Someone might say no, it's probably 1.18. That's okay, because the last digit is estimated. And that's how we got those numbers for graduated cylinder. So remember, there's 1 you can go for certainty, what it is, and then you can go one more digit that is estimated. All right, so in lab, pay attention what glassware you use, because depending on what glassware you use in lab, you can report different things. You can report your significant figures. If you use a beaker, do not ever use a decimal place. Don't say I measured 25.0 ml. You use a beaker. You can't be that accurate. But if you use a 100 ml graduated cylinder, sure, you can say I did 25.1 ml. So be careful what glassware you use. That is going to determine your significant figure. All right, pay attention in lab. Nice job.